conference.
Hello everyone, and thank you for having me today. My name is Fuzia Ajalia. I am an Algerian citizenship, but I'm a PhD student at the Technical University of Košice in Slovak Republic. And today I will be presenting our research, which is entitled as follows: Deep Learning-based classification of 2D and 3D images for facial expression recognition. It is a comparison study. So our presentation will be divided on four main parts. We will start with the basic notions of what is facial expression recognition, and after that we will describe the dataset that we used. After in the third part, we will explain about the experimental setup, and finally we will conclude our work with the results and the challenges. First of all, we'll start with the objectives of our research. One of the main objectives is to provide the basic outlines of both two-dimensional and three-dimensional facial expression classification, with a number of concepts in detail and the extent of their influence on the classification process. Second, compare the accuracy of two-dimensional and three-dimensional proposed models to analyze the 2D and 3D classification using comprehensive algorithms based on convolution neural network. Facial expression is considered as the fastest non-verbal communication challenge between human beings, because it's the first thing that human beings see when they have a direct communication. And also it has a lot of applications, like in health, when they try to monitor the patient's emotional state and try to engage with those people who, for instance, have depressions or they feel sad. Also another applications in education, when they start to monitor the emotions of the students, and furthermore they try to improve their emotional state in order to increase their productivity. Also in security, and also in robotics. So we will try to understand what is facial expressions from a psychological point of view. From psychological point of view, there is a difference between feelings, affects, and sentiments. Feelings can be driven by physical states like hunger, pain, and fatigue, as well as emotional states. However, affect is the state of evaluation and situational behavior by two forms, negative and positive, that is like and dislike. However, sentiments, which are socially constructed patterns of sensations, expressive gestures, and cultural meanings organized around the relationship to social objects, usually another person or group such as family. So it can be in a form of a romantic love, parental love, loyalty, and friendship. However, from physiological point of view, facial expressions are resulted by a consequence of mimic muscles activities that interpret by the facial nerves. You see in the picture, then for instance, the happiness is resulted by the movements of the mouth and the eyes, and the wrinkles, for instance, beside the eyes. And the first experiments that were done by Ekman. He had this tribe in Africa, and he tried to know their emotions, and he after that came up to the conclusion that we all as human beings, we share the standards and the common facial expressions, no matter what is our ethnicity, and no matter what where are we from. But we would like to know how computers understand our emotions and facial expressions. For this matter, we have emotion models. Emotional models, we can distinguish two categories. We have the categorical and the dimensional. In the categorical, for instance, we have the basic, the hourglass facial action coding system. In the dimensional, we have a plastic model, visual model. But what is the difference between the categorical and dimensional models? Well, in the categorical models, the core is that all humans have an innate set of basic or fundamental emotions that are universally recognized. Basic emotions are considered discrete because they can be distinguished by facial expressions. The most popular example for the categorical emotion, as I mentioned earlier, is Ekman's 6 universal emotions. That is anger, fear, disgust, surprise, happy, and sad. However, in the dimensional models, it's based on systems of emotions that can be represented in more than one dimension. To achieve this, they incorporate intensity, valence, arousal dimensions according to the needs of specific model. You notice here in the picture we have two axes, and we have emotions between those two axes. So it depends on the arousal, valence, intensity. So it has other dimensions rather than the categorical one. In our experiments, we used one famous dataset, which is called Bosphorus dataset. It's a Turkish dataset intended for research on 3D and 2D human facial processing tasks, including expression recognition, facial action unit detection, facial action unit intensity estimation, face recognition under adverse conditions. And here you notice that we have the 2D images and the 3D images in the shape of meshes. In our experiments, we used as I mentioned, the Bosphorus dataset, and in order to allow the classification process to be carried out in a more sophisticated way, we avoided applying any major pre-processing techniques for both 2D and 3D images, as well as avoid applying data augmentation just for the sake of having a fairer comparison. We used 453 two-dimensional as well as the same number of three-dimensional images in the type of point clouds. We split the provided images into 80% of training and 20% for validation. And the picture represents the distribution of the training and the validation sets. The hyperparameters used for our experiment, it's the same for 2D and 3D classification, as I said, for just have a fair comparison. We use 20 in the mini batch size. The learning rate schedule is piecewise. Learning rate drop period is 40. Max epochs is 40. Initiate learn rate is 0.2. Solver name stochastic gradient descent with momentum. The first experiment regarding the 2D classification in the data pre-processing, we didn't apply major pre-processing steps. We had just the grayscale and resized the images to 30 by 30. And the picture represents the architecture that we used for the classification. It's a convolution neural network with the 3 blocks. We have a convolution layer, batch normalization, relay layer, and max pooling layer. Second thing for the second block, and the third block, the drop layer to overcome the overfitting, fully connected layer, softmax layer, and classification layer. However, in the second experiment, the input data is different than the first experiments, obviously, because it's 3D data. So the Bosphorus data set, they provide files in the extensions of BNT, it's binary file, and we converted those binary file into point clouds. After that, we applied some downsampling or uniform downsampling just to uniform the data. So here, those are the point clouds of the face. This is a happy face. However, we want to make a voxel classification, not a point cloud classification. So the second step is a voxelization. So we read the point clouds After that, we changed the point clouds into a voxel by applying a function called occupancy grid. So instead of points, I have right now voxels. And right now my data is ready for the classification. We use again the same architecture. However, we changed the convolution 2D layers into convolution 3D layers, and the same thing for max pooling. In the first experiment, we had max pooling 2D max pooling layer, and here we have 3D max pooling layers. And in the results, we found out the accuracy of 2D classification achieved 85% for the training and 75.56% in the validation. As for the training loss, it reaches 0.37 and 0.7 for the validation loss. However, in the 3D classification, we obtained the 65 of training accuracy and 48 more, like approximately 49 of validation accuracy, as well as 0.4 in the training loss and 0.6 in the validation loss. This represents the convolution matrices. So this research has demonstrated a comparison study for facial expression recognition. For this purpose, convolutional neural network was used to classify the 2D and 3D images from the Bosphorus dataset. For a sophisticated training process, we applied the same experimental setup and hyperparameters. Along the observer study, it appears that 2D classification overall produces slightly more accurate results than 3D classification. This is because 3D voxel classification is still a very new research area. So further studies should be performed to create more 3D data and to develop methods for 3D data augmentation, as well as proposing a better voxel classification model. So those are my ultimate goals in my research as a next step in my research. So thank you so much for your attention, and if you have any questions, I will be honored. And if you want to contact me, then this is my email address. Thank you.